Thank you so much. It's with great enthusiasm that I'd like to welcome Director Paul from PwC, PricewaterhouseCoopers, today. So Director Paul holds a master's degree in Information Systems and Management from Carnegie Mellon University, as well as a bachelor's of Science in Information Science and Engineering. He is currently Director of Artificial Intelligence Engineering at PwC's Commercial Technology and Innovation Office, where he leads the design and deployment of AI systems for complex, high-stakes business environments. This actually includes a lot of life sciences work involved in healthcare, healthcare finance, and cybersecurity. He's been involved with developing pharmacovigilance systems, clinical trial design, content MLR review, cybersecurity risk analysis, large-scale audits that all make what we do in healthcare possible. I thought he'd be a very interesting person to bring to the table because outside of his particular technical expertise, leading a consulting group allows him to have cross-sector interactions with other clients, from healthcare delivery systems to pharma to devices. And additionally, in contrast to many of us here, in addition to being an evaluator of science and evidence, he's also a developer who's able to turn those technologies into insights that are actually deployed for production use in the real world. Without further ado, I'd like to invite Director Paul to give his presentation, and I hope that you guys can think of some great questions for him because we want to make this as interactive as possible. Thanks so much.
Awesome. Thank you, Andrew, for hosting me. Glad to be here and look forward to, talking about a bunch of stuff that I was thinking of. Andrew read through the things I was playing in my mind in terms of the introduction that I need to talk through. So I'll cut to the chase in terms of the specifics. So I have about a decade of industry experience working in data science, machine learning, basically within PwC. Again, surprisingly, to many people when I bring this up generally is that it is a consulting firm, accounting firm. I've always been part of this innovation and research group, and our focus has always been stay at the cutting edge of AI and deep learning specifically when it began around the 2017 era. And the goal was to build out prototypes and be a practitioner out there in the industry to, actually have applied AI solutions sit in the enterprise. So that's kind of my background. It has come down to a point where I do the same thing pretty much. It is the same exercise, go in, talk to stakeholders, identify the problem, get the data constructs in place and try and build a solution that is lasting, that improves over time, all your regular fixtures there. So, close to 7 years, I've worked with different industry counterparts, like Andrew mentioned, different industries like pharma, financial services, cybersecurity, etc. But over the past year or so, kind of shifted focus back internally to PwC's accounting business and the accounting practice, and dealing with that almost as a microcosm of a single domain, where we're trying to see what we can enable with AI, with an auditor as our primary entity of focus. So I'll primarily be talking a lot of detail and specifically about the transformation program we have going on with our audit practice. And in terms of where the topic came about, and this was Andrew giving me some cues for what might apply here, and just thinking through that, what came to mind was that there's been a lot of change in our industry. And again, we've not been unfamiliar to change over the past many years or so, but it's gotten so rapid and there is no continuous flow to it at this point. It is really stepwise changes that just randomly take away or, send into obsolescence a whole bunch of solutions that we're building. So a lot of our focus is how do we future-proof for this kind of a current state? How do we build some of that forward compatibility? So it comes down to a sense of, again, system dynamics. And there was a portion of our group that consistently focused on simulation modeling and system dynamics in a traditional sense. But it is coming down to a factor or a form factor where the organizational ecosystem of AI operating across the board is starting to look like, a digital twin. which is kind of what we spoke about. So I'll go through different levels of how we see this operating and what that means in our era of constant changes. And we'll talk a little bit about the governance architecture that we have in place, sort of setting it up to continuously evolve, things like that. And then sort of trailing off of that, I think a core observation in the industry has been there is this divide slash gulf between a domain expert and their experience with AI and an engineer and their experience with AI. And they have a lot to gain from each other in terms of just the understanding of the other's world. And we've been working on systems that enable some of this bridging between the two groups. So we'll be talking about that in the latter half of the conversation. So again, I'll stop for a few questions, and then we'll move on. But feel free to, just bring up anything. Want it to be as interactive as possible. So the first item that I want to cover here is basically what we're looking at. What's the fundamental difference in terms of what we used to see previously versus what came about, say, in the last year, in the 2025, 26 era, is what we can think of it as, right? So there used to be all of these models that you query versus now you have systems that act on their own by virtue of, a few different reasons. One is that the models learned how to reason. That is because the fundamental thesis of, just throwing in more data and then scaling laws coming together. Scaling laws just generally as an introduction means that if you throw a large amount of compute and a large amount of data together, you just get increased intelligence, right, in an empirical form. And that is generally what the language model scaling laws state. But the, we saw that plateauing around the past year. So a lot of engineering sort of came around it, which is kind of where you see things like tool use, memory management, a lot of details in terms of context engineering. So that became commonplace. And the reasoning loop basically worked because of something called the verification model, right? So specifically reinforcement learning through verification as rewards. And that meant if you have any system where you can place an objective function that can automatically check for itself, things like math, code, etc., then you have models that can reason through their work and come up with better outcomes. And there is a mechanism through which you can improve them, right? So with that being said, moving on from there, I think just a comparison of the generations that we saw is an AI can assist with a task is what knowledge workers are familiar with. You go in, you go into your chat GPT console, your Claude console, and then probe for a bunch of things. You work through it. You're primarily relying on the features that these big labs are providing through that interface. Whereas the current generation is, again, specifically in the engineering worldview, you have these agents that can go in and execute tasks for you. I think this is present in all of your major lab provided consoles as well. If you use one of those thinking models for an extended period of time, you can see a reasoning trace where the agent is thinking through things. What it's necessarily doing isn't, next token prediction or the word completion analogy that we bring to language models in general, but it's sort of going through another engineering loop where it's, trying to execute a particular outcome. Yep. Sure.
You'll need to repeat the question. This slide begs the question, what's next? Are you going to talk about what's next, or is that a question?
No, we can certainly talk about what's next. I've kind of kept it very zeitgeist, if you will, to what's in the industry. But I think just in terms of like long horizon tasks and the long horizon window increasing over time is what we're really seeing as next. But we can have that during the discussion time. So I think fundamentally what changes here is you have a system that executes certain activity, and what people are finding, and people includes people like me who are building systems for stakeholders that have very precise business objectives, is that you can chain these things together. There's no necessary end to it. So you can execute sequences of tasks, you can execute an entire profile of a process and eventually an organization, or try and mimic a persona through agent behavior, things like that. But that also brings in a big question around governance and what does it mean from a systems perspective, because you're not necessarily checking one answer to try and see if it's correct or mistaken. You're trying to review a system. So there is verifiability that needs to be built in across the entire system to try and say that this is reliable, this can be used, and a lot of detail and a lot of time goes into doing that. That's one of the primary takeaways that I wanted to bring up, is that development time is the cost of development, and code generation is so democratized at this point, is that getting something functional is 1/3 of the problem, but building out the metrics, building out the reliability, and then even the qualitative structures around where it can be used, what are the alerting frameworks, that is really where we spend our time, which is the change that we're seeing. And obviously, there are some economic incentives to this as well, just given the way the market is operating and things like that. So you see more direction in terms of, everything sort of going down the path of code as a mechanism for you to be producing things. Um, but that's kind of what we've observed over the last 6 months or so, I would say. And busy slide here, but I think pretty common at this point for us to describe a lot of specific detail. And I think this is a neat way of generally, thinking about AI capability, because one question that comes up naturally is, as a domain expert, more so as a domain expert, right? Even outside of the fact that you're an engineer, because I will have to, in my role, serve somebody who's in the healthcare domain, very high bar for what that means from a governance perspective, versus someone else in finance, like arguably slightly lower bar. The same way. So we look at domains very objectively, but the idea is that the capabilities of these models, again, this is where it goes back to uh, the core thesis that language models are an empirical fact. Like, we don't necessarily know why throwing more compute and data gives us better intelligence, right? So the capabilities are that jagged frontier that you see. So seemingly similar tasks, sometimes you find that the model may not do pretty well. And I think this is where the domain expert really comes in, and their judgment is what's necessary to identify what falls within the boundary versus what falls outside the boundary. And in terms of where we stand right now, I think the speculation, again, very speculative slide here, right? Um, it sort of marks a big change, big step function improvement, you can say, from where we're at going to where we're going to be next. Probably the mythos model, or like whatever they were talking about last week. And then I think there are some other schools of thought where they say the blue circle is really, the intelligence that mankind needs specifically to, satisfy a lot of the enterprise needs, the business needs that we have, the way the market is sort of, thinking of all of the impacts of what we need AI to be doing. But the growth or the intelligence increase in terms of what might come up later might entirely look different, and it might cover regions which don't necessarily apply, and we don't have the domain knowledge to even figure it out. So a few different pieces there. I think the takeaway really is that with things that are verifiable, I think it comes down to verifiability. That is the story of the previous year, because we take these basic language models, and then if something is verifiable, we reinforcement learn through just trying to produce outcomes, making sure that the model is in line with that objective function. Otherwise, you're going through variations and just going through your general training loop. But the gaps are things that would ideally fall in your domain. Again, forgive me if there is anything presumptuous about your world here. This entire deck was again generated by AI, not a word was written by me by hand. So I will pawn it off there. But I think it's very hard to verify in your world, just specific clinical judgment, I would assume, even with the right source information. There's probably a combination of different things that you would need to think about in order to verify it. Obviously, again, like there are specific, verifiable outcomes where numbers are involved specifically, like lab results and such, I would think. But policy and other nuance requires a domain expert to firmly be in the loop, which is kind of what we will talk about. Um, yeah, so the spikes and gaps are interleaved, as you can see, and you can't deploy something at the spikes and just not identify the gaps in a real world setting that actually has implications for the outcomes coming from the system, which is true in the case of the audit work that I was referring to. One example to cover here really is, everything that I've been referring to in terms of like the verifiability and the updates and like the changes that have come in over the last year has been the fact that scaling saw somewhat of a plateau. So people started going through different methods to try and increment performance, which is where we hear about Cloud Code every single day. But the idea is that there were some engineering elements brought in, like tool use, file systems and terminals, and like you get in there, and that's where you really operate. Retrieval augmented generation changed, and right now you can just directly go into file system, and you should be able to, search for a particular file, get your relevant context. There is skills in the picture. All of these are sort of engineering constructs that have come in order to improve ability. And when one of those bottleneck changes, or you saw those gaps within the jagged frontier, if one of those improves, then it provides a step change on everything related to a particular domain. And a primary example was slide making, for example, right? Or where people were trying to use code to generate slides, never really worked well, even though code generation models were great for other purposes, primarily because, again, the underlying system is a statistical representation of code. So it gave us some thinking to do. And that's where, when Google came up with a very good image production model that overcame that liability or limitation or gap that you saw in the jagged frontier. And suddenly we were able to make much better slides, right? So that is an example of that one gap holding back an entire exercise or an entire domain of what needs to happen. So hopefully that, you know, um, explains what I'm referring to, which is kind of what we also keep an eye out for whenever we are thinking about problems out there with any stakeholder or any industry that we're dealing with. What are the gaps? How can we track that so that, once we're aware of a new piece of technology or a new method coming in there, can we go in and, include that to try and get that step function variation? So in terms of real world enterprise environments, and this is where, like Andrew was mentioning, I've almost always operated in a world where there are a lot of controls. And those controls mean you have to come in with a lot of evaluation and monitoring fixtures for the systems that you're building, right? So currently, we know that agents can execute real work, but we also know that capability is uneven. There are things that it consistently fails at. And we know that the people involved in building it, which is one is the engineers and domain experts, sort of see the underlying technology slightly differently, right? Just based off of their experience. Obviously, there are outliers in both groups, but how do we deploy at organizational scale and make this work for any given industry? Given these findings or like these changes that have occurred recently, which is what I'll try and cover here is digital twins at scale. How do we represent some of these agent systems as processes, as something that, mimics a practice at a professional level for an entire organization, and then how that manifests into an individual persona that an agent can operate as. Those are, again, increasing levels of complexity. I'll go into why that is true. So I will stall there to see if there are any questions. Okay, so talking about digital twins for the agentic era, again, I'm not someone who's extremely well versed in system dynamics and the way that you create simulations in order to model outcomes and use that for decision making. But aware of that process and the fact that you can do a lot of that, especially with, biological systems involved, things like that. I think you're really trying to mirror a system within that space. There is a switch, or, in terms of the definition of what I'm appropriating the phrase digital twin for. Here I'm referring to the fact that, a system with agents at its core, because an agent ecosystem sort of manifests as a digital twin performing operations, especially when we're thinking of it not necessarily as, hey, I'm doing a process right now. Can I use AI to automate it at particular points? That kind of scratches the surface, but can you fundamentally change the process itself and make that AI native? In which case, I think just like thinking of this as a twin mechanism or a parallel, system that can really operate to do the work that a human is doing at a particular point is helpful, which is why this framing. So the three layers that, again, personally I've observed building out a few things over the past year or so is what's common is, there is a problem, there's a particular process, a singular process that, a group of people do, part of a business unit. What you're doing is you're trying to mimic that through chaining a bunch of language model systems, or like chaining a bunch of agents, and then producing the outcome, which is the sequence that you're seeing in the first layer. I'll go into a concrete example here, a simple one. And number two is you have agent systems coordinating with each other. And this is sort of a snapshot in very simple terms of the audit work that I was referring to, which is, again, a company with a 150-year-old history in the industry. So, that we're instrumental in writing a lot of the book on the methodology and things like that. So when we're thinking about re-architecting or refactoring what that looks like in this agent-based world, we're capturing that through, agents that operate as processes, but then there is connectivity amongst all of them. There is a governance layer that sort of sits beneath it, right? So that with it comes a feedback loop. You're chaining the outcomes from one system, getting fed into another system. So there are downstream value additions coming, and there's a feedback loop going in, and somewhat also allows for information exchange, because when we're thinking of it from a product perspective, you want to create network effects for people using the tool. So that's a representation. Again, I'll get into some detail there. Thirdly, I think this is complex because, again, like when you generally think of it, the way that I would have thought very initially, naively, without having experimented or done anything, is that, and for an individual agent, you get in a bunch of context and say, here, go be an auditor, right? Or go be a clinician, go try doing something, because I'll give you the textbook on what needs to be done. That is possibly the hardest systemic outcome to mirror, if you will, because there's so much judgment that needs to go in across the board when you're doing different tasks. Is, compartmentalizing that, breaking that down is not necessarily the simplest of tasks as of right now. So, which is what we're referring to. There is an individual agent, however, that we created, that we find success from, goes back to the verifiability concept. We created an individual agent that mirrors our own work, which is an AI engineer agent. You describe a problem, it will try to come up with these solutions, and there is a method to how you go about that. And I'll talk about that a little bit. So foundationally, what's true for all of these things? Again, I think this audience is pretty primed when it comes to the background of AI. So I won't necessarily get into the detail here, but happy to take any questions. There was this era of prompt engineering where you wrote a system prompt, consistently held that, did your custom GPTs, etc. And then there were a few methods that you operated with in order to try and mimic a process. These days, it's predominantly, especially things that we've developed last year, is a lot of context engineering, because you want to, context engineering, I think in plain English, just means give the agent the right things to look at the right time in order to perform a particular task. So it is temporal as well as, a a lot of memory management involved there. So people also call it an art and a science because, it isn't necessarily an exact science for you to be grabbing something and then producing certain outcomes. So all you're trying to do is show the agent the right things in order to do the best possible job at that particular point in time. Where we're trending towards is harness engineering. If you've heard of things like Cursor or Claude Code, these are harnesses typically. And why harnesses, right? Like, I think that's a question. And there are many people who kind of want to cut the jargon and say it's all pretty much the same thing. You're just trying to get the right pieces of information to this AI system at the right point in time. And it doesn't necessarily matter how you're going to phrase it, or like, if you can come up with 100 frameworks, it is the same effective outcome. But I think the fundamental difference, and this is an opinionated view, is that with harness engineering, there are a lot of engineering constructs like, tools. You create hooks, you create questions that you want to probe the user with to try and gather more information. And this creates a system which is able to, well, the objective of a harness is that you should be able to harvest more intelligence coming in from an updated model. We haven't seen GPT-6. If somebody comes in and says, you created this chatbot, is it going to get better with GPT-6? The theoretical answer is no. But with harnesses, you are creating that separation of concerns so that whenever there is increased intelligence, you should be able to harvest from increased intelligence so that you don't have to go in and like touch it repeatedly and keep it sustainable. That's kind of the ideation, which is why I think it is important for people like us to work through the harness-based variations, A/B test them, etc. So quickly running through each of these, right? The process level twin, this is an example from the audit world, again, simplified here. But an audit in its essence is basically you're reviewing all of the transactions, let's say, within a company, and you're trying to test if those transactions are recorded appropriately and if they follow your basic guidelines financially or otherwise, right? There are certain times, some controls that you need to test for, but effectively what I'm trying to suggest is testing is a core part of performing an audit, right? So this is an example of a test. So imagine you're testing the revenue reports that's been produced by a bakery, for example. Then you go in and you ask them to produce a bunch of receipts. You ask for a bunch of support information that you want to utilize in order to say, I did this test. All of this company's numbers look good. They're good to go. I'm signing off as this knowledge worker that has a particular license to say that, this is audited and this is good. There are some key parts to how we act in a situation like this in terms of development is we create an orchestrator agent that basically runs the show. And there is a data preparation agent which comes in, which identifies all of the pieces of data, assigns, some metadata tags to it, et cetera, and then does the extraction. Extraction is really the fundamental problem when it comes to the pure machine learning angle, because you're looking at so many variations of documents, you're looking at, different formats, things like that. So that is really the technical problem to solve. And there is a nuance in terms of how you're comparing that extracted information with recorded request, right, for example. And then finally, you're synthesizing things. Now, the question really is like, why is this the right outcome? This isn't. It's one of many right answers. What you're really trying to do is match your governance framework for how you're evaluating the system to be fit for purpose, and then releasing that into, a real professional practice for people to use, apply on their jobs, things like that. So that was a story around process twins. But again, you see this article was launched, and my boss is quoted there, but the idea is that our company wants to end-to-end automate uh, the entire practice of audit, as in like AI enable or like provide support for people to be performing their audits with. Now, how do we do that is just double clicking into that schematic that I showed for the organizational level digital twin is This for me is almost a system dynamics, systems engineering diagram, because you have different components, which are all agent systems under the hood. But there is a relationship here that is, very dynamic. It's a living, breathing system because there's feedback loops. There is, better understanding that goes in ultimately to grow that system. So I've identified like a few points. There's a lot more to this in terms of the end-to-end spectrum of audit, but helpful to think of it as like I plan for an audit, I assess the risk given a company, given the context that I have. Then I walk them through their processes to make sure that I'm understanding their processes well. This is an actual audit task. And then you perform evidence, like you ask for a bunch of evidence and then you test to see if it's actually tallying, and then do some financial statement reviews to make sure it all matches, and then you close the audit, right? So that's sort of a sequence. The way that it works though is, like planning is fundamental. So if that goes wrong, you're obviously going to have problems within testing, right? So how do we work that out is what I'll talk about next, which is really the governance, that framework that comes in. But you also see, in some sense, slightly exaggerating the organizational memory bit, but the idea is that you have learnings coming in from all of this usage, right? So there is usage of these systems. There is obviously some data sensitivity involved. So we have to be specific about what kind of learning methods we use, what data is consumed for us to learn from. The reasoning traces get anonymized, and we're really identifying themes, for example. So once we do that, we have, criteria running. So with more usage patterns, we have more decision traces, things like that to pick up. So we have more feedback signal, and then the system continues to get calibrated, right? Eventually, like, why should I be going and using the system? If some auditor asks us that within the company, that's because there are thousands of other auditors already using this. So, their usage is consolidated into some means of information that you would really want access to, right? So classic social media playbook, network effects there. Again, like we're yet to see that manifest into a lot of use. We're seeing a lot of value through education, as in like we're bringing them an average representation of what a good process looks like. And that is being found very valuable by a lot of our domain experts. So what's really important here, and I'll keep this one brief, is there are three phases to creating the sort of a digital twin or a system is, pre-deployment for every single system, which is during development, you're evaluating your system, making sure it's fit for purpose before it's sent in. And then once it's running, you want to monitor every single outcome. You have to have hooks in place to make sure that whatever I've developed hasn't regressed. It hasn't completely gone off the rails on any given day. And trust me, like that does happen, and there are ways for us to work through that. But yeah, I think that's where a lot of our metric setting and the way that we set up alerting thresholds, which is where a lot of work happens, even technically, because, and this is what I keep talking to my team about, is we're talking about us being an AI engineer, but then the bridge between, an AI engineer and software engineer is sort of coming together at this point. What we're really supposed to do is sit down with domain experts, hear what's important to them, and be able to mathematically model that into some sort of a verifiability function, right? Like it's really converging towards that, which is kind of where we have to put in the work in order to set up the right monitoring systems. And then post that is you have some ongoing monitoring and governance related items where you're periodically reviewing things, periodically generating reports out of the usage that's been going on within a system. Right. So I spoke about the AI engineer agent, but this is where an individual agent comes in, where you're trying to reflect a persona within an agent. It's generally quite hard to do, is our finding, unless you sort of, do it as a toy example. For example, there was this particular series that was out over the last month where Gary Tan, the CEO of Y Combinator, created a system where, he was automating an entire company, as in he had a marketing manager, he had a sales manager, he had an accounting manager, and then he just created a bunch of skills for all of them. It was really representing the company as an individual, right? But again, there were so many shortcomings for that to actually be operational in reality, which is the difference that I'm highlighting in terms of the top examples that we see out there um, on the news versus something that's operational and real, right? So the AI engineer agent is really something that takes a problem. We say, I need to create this evidence matching or testing solution that I showed you for that particular process. I'm just going to probe it in real natural language. It's going to give me a component-wise breakdown. The component breakdown is the component set that you saw there. Do I need to be doing data processing, extraction, reconciliation, synthesis, and so on? And if I approve and say, okay, this looks good, this looks like it's comprehensive enough, what it's going to do is it will prepare test data based on things that I've supplied, and then it'll generate multiple different strategies, approaches to go about that particular task, and then evaluate every single approach, give me a list of metrics. And all I'm supposed to do is approve yes or no for it to continue that loop. And at the end of that, I just have a working solution produced. And we did this sometime around December. Things have rapidly improved since, legitimately in terms of like how you can use one of these systems. If you're familiar with something called auto research, it's basically a lot of skills put together in order to automate research, right? So the power of this is that it's just you run a bunch of details by configuring a particular exploration, and then it runs in a loop while you're asleep, and then it'll have produced results for, say, 5 experiments by the time you're back up. That is the promise. Again, it works surprisingly well in comparison to what I had personally expected, right? So I think definitely something worth looking into, because that's where the engineering and verifiability comes in. Because for all research, there are benchmarks that you're looking at, there are numbers that you're working through. So in terms of like where I come from, what was enabled for us to be able to do all of these things, we have a federated system, as in I sit in a central AI engineering team. We work with different groups, different sectors, and we get paired up with domain experts. Like, engineers on my team will be paired up with actual domain experts who will talk to them, who will review the prompts and will review the system and tell them if it makes sense. And then it's a consistent engagement. It doesn't end. Like, they know who to call if something goes on with their ownership of that particular outcome. So that federated model consistently works for us because it's also a community that we can keep close, and then our growth happens consistently because we're in a singular node. And then finally, the infrastructure flexibility is one of the great boons of working for like a large corporation. Is we have access to all model providers, good capacity in terms of just being able to use all of these tools. But that is again fundamental to us being able to drive in this direction. Some field notes, because this whole thing was meant to be a field report, which I forgot to mention right in the initial intro. But the governance architecture is the hardest part. And by this, I'm also referring to the very technical detail of creating evaluation metrics and monitoring metrics for how you will measure your system's quality and what that means for a user, for example. That is where we spend, about half our time. The co-creation aspect of this, which we'll go into next, is the value really is with domain experts coming in and us giving them the right avenues to contribute rather than them reviewing some results in an Excel sheet, right? Like, we're trying to build systems where we can get their preference data, where we can get them to write free-form text, really critiquing an outcome. I think that's where most value lies, because we see improvements or, significant uplift comes in after a domain expert generally, makes a particular move. One other principle of ours is, again, like, this is my personal understanding, is just how the United States is exposed to AI systems is primarily through chat, which isn't necessarily true everywhere, because it's the same underlying artifact of intelligence that we use for all of the other systems that we do as well. Certain times, it does not resemble anything like your ChatGPT experience or like the chat-based experience. None of the tools or like the stuff that I showed you up until now actually is based off of, somebody probing a question, because the principle here is that then you're assuming that everybody within that domain has the knowledge to ask the right question. So we're not going to pawn off that responsibility to the user. Rather, we're going to create a guided workflow to represent what that task needs to look like. And then in many cases, it operates like a SaaS application, right? Where they go in, they're uploading data, outcomes get produced, and then you're progressing downstream. Now, can we merge this with chat interfaces? There's this whole new paradigm called generative UI. So you can preserve this workflow, but then bring that into a chat, because when you're asking the right questions, the workflow pops up, right? So that's in the direction generally, because the user interface is part of the product. It's not necessarily just a means to communicate with the user. So as the last thing here is that, again, this is Claude being slightly presumptuous, but your domain, as in like, the research domain and the clinical domain, is known for building structured knowledge representations, and it has a lot of importance in terms of making sure you have the right taxonomies, ontologies, things like that. I think we're seeing new gains in the space, right? Like the whole preservation of knowledge, how you search through a file system, how you give these models access to your structured taxonomies. I think that's kind of where there is a lot of value to be had, which we're certainly doing in this particular space as well. And I think the last thing to communicate here is, even though there's so much governance, there's so much guideline-based rigor that comes in, it's still, our errors are financial, retrospective. All you will probably need to do is like reissue an audit, reissue a financial statement for the company, things like that. But within critical domains, there is, physical implications, irreversible implications. So I think that probably changes the risk calculus a little bit. So I think it's important to consider that the structure exists, but the calibration of what that needs to be is probably going to be different. And just in terms of, organizationally, like where we stand, and just given the fact that we've developed this, organizational digital twin, this post came out a month or so ago, is we're finding these pieces that sit within that organizational digital twin that have effects across the board, right? Like it isn't developed for one solution. So one such thing was we were able to create a best-in-class spreadsheet reasoning solution. Microsoft had an incumbent solution called Spreadsheet LLM, and there are a few variations of that, but we were able to beat those benchmarks and then internally apply this, because everybody uses spreadsheets, right? So you should be able to reason over those spreadsheets. And once we made that change or affected that change, it started having ripple effects across that entire digital twin for the organization of the practice that I was referring to. So just one of those tangible outcomes. We have a little over 10 minutes left, but I think a central bottleneck that we see is this interaction between domain experts and engineers, right? Because I think cutting to the expertise gap, and I thought I made this funny picture here, but the idea is that there are people who understand the domain, people who don't understand the domain, and people who understand AI capability and people who don't. They're fundamentally two populations, and this includes somebody like me. Like I am pretty clear on the scalability and the capabilities that AI can produce in terms of just being able to run across large data sets or batches of information, how it can, systematically provide value for a process. But I have no idea about what AI can do when it comes to like, some genetic detail or like, gene therapy research, for example, or something like that. That is where the domain expert needs to tell me that this lies within the jagged frontier versus this lies outside the jagged frontier, which is where I think the ideal that you're looking at, and this has been terminology for a while, is that you have the centaur model versus cyborg, where centaur is you have actual human in the loop at very critical points. And that is the ideal person because they have an understanding of the AI capability, and they also know their domain and what AI can do in their domain. So they become very vital to our whole operation because they can help inform that boundary of the frontier. So everything post this is what we are doing in terms of, just engaging with domain experts or trying to get them into that centaur bucket, right? So there's a flow in terms of like what we're trying to see. There is latent capability in a language model. It has learnings, but if I probe it for a particular research question, it's probably going to, give me an answer which I'm not going to be sufficiently happy with. But if you probe the same model, you're going to be able to unwrap that latent knowledge, or like, you're going to be able to tease out that latent knowledge. And our job is to create systems in order for that to take effect at scale. So that is where the practitioners come in. A couple of examples here. I'll actually go to the pharma example. So we had this case where, we had to build in systems for pharmaceutical promotional content to perform regulatory checks on them, because obviously, that's kind of where you see even HCPs receiving these pieces of promotional content. They need to be seeing the benefits and risks. So together, there is a balance between the size of the image and the risks being listed down. There are plenty of rules, in other words, right? So we thought we could go in, use raw data sources to create a system like FDA warning letters, for example, within a particular enterprise, and then generate these checks and then run all of those checks on promotional content. And we thought we could create this self-evolving system where we could just create this repository of checks by engineering systems that just pulled from data. Did not work, right? Because once we sat in front of a domain expert, they say this is an extremely outlying case. You don't have our distribution captured at all, right? So that's when they sat with us, wrote a bunch of specific checks that are of value to them. They use that every day at this point, right? So I think something as preliminary as that, like you think you can engineer your way out of it, it's not going to work, is where I think we're trying to find clarity there, especially within this audit world, within everything else, right? Um, so again, specific example here, we've spoken about verification, hard to verify domains. The hard to verify pieces, even with something that has verification built in, like code, which is the example there, is that, just the flip side is true as well. There are so many domain experts that we deal with right now that are coming out with apps and saying like, hey, I've solved this problem, right? Like I know my domain. I can also engineer it because Claude Code just gives me the outcome. What we find is that there's a major gap there as well, is, the whole IKEA assembly of that system needs to happen. Both the fact to get it to production grade and get people to actually be using it, producing value, and for that whole organism to start, growing. That's where a significant gap is, which is where I think we spend a lot of time. The governance aspect comes in there as well, right? So for hard to verify domains, I think there's a structural need for domain experts to come in, and the mechanisms through which we bring them in is creating the right kind of harness for people to go in, annotate, give us the right pieces of information, right free form text, which we can topic model, for example, and then co-creation, like always put them in a pod, pair engineers together with domain experts so that there is like cross-pollination of just knowledge. And I think finally, there's a framing that is necessary to elevate both their roles as well, because I think when we call out for domain experts to, come in and say, just give me like preference information here in terms of like outputs being good or bad, they're generally disinterested. So we really want to define that in a way that gives us most value as well as keeps it interesting for them. So the harness needs to be designed that way. And for engineers, I think just raising the stakes in terms of like, how are we phrasing this system? What are the opportunities you have in terms of like opening this up further and creating really a system that is lasting? It's probably the means to attract serious people, right? So I think the storyline here is really for industries, that have critical outcomes depending on AI. You really want to close the gap between experts in both spaces and get them to understand each other's world. So on the intersection, there's a few concepts that can work, right? Like primarily evaluation, like if we want to mathematically model how we measure the system, those frameworks. It's gotten to a simpler format now where you can just, dump your thoughts in an agent skill and it's quickly and immediately valuable to somebody engineering a system. The knowledge compilation piece is, we used to perform retrieval augmented generation, relied on mathematical operation, looking at the semantic similarity of sentences, things like that. This has changed because something like a Cloud Code just searches your file system, right? Like it can just look through your file system. So that could apply to any domain. You could get all your research files, just throw that into a computer. It'll do file search on it. So much better than your retrieval-based systems. That's how Cloud Cowork works right now. And then finally, and this is something that Andrew has been looking into my understanding is just bilingual representations of data, right? So you have translations or you have embeddings, which is sort of a fundamental factor of how we develop and like compare outcomes here. So you could have like a bilingual version of that, which sort of, has that translation built in. So your similarity search is already looking for what's important because it has been trained that way. So finally, I think, some of these systems, like we talk about this, is they are real, they're being built, they're being used, and that is going into a feedback loop, consistently improving these systems. The major missing piece there is how we build in the governance system around it, and that is a very technical problem as well. So it requires domain experts and engineers to work with each other, right? And the central constraint or the gap is really the expertise gap that we were referring to. And with all of the knowledge representations that are available, especially in the clinical research field, I think you can work with our current state of AI and be able to produce these outcomes, especially if that pairing between your domain expert and your engineer happens, right? So that's kind of what the last line here is describing. And with that, I think, just back to Q&A.
We have a question from the online community.
Yep.
How might you recommend for us to keep up with best practices for usage of AI, given the rapidly changing landscape? It seems like scientific journals will not be able to keep up with the speed of innovation. So I find that tech news, articles, and blog posts start to emerge as the de facto source of best practices. Is that the best source these days?
It is, but even that is not foolproof, right? Like it's hard to keep up with tech news as well. But generally, I would say like Twitter, Reddit, and Hacker News, things like these, like have the right things, getting surfaced. Especially something like Hacker News, like it has a naturally inbuilt algorithm to, surface things that are important to consider. For example, right? So that's what it's. But it's impossible to keep up. Like that is one truth.
Great talk. Thank you for being here today. Two concepts that your talk reminded me of or emphasized, and that is, so harness is the word du jour. We're starting to see that, and I think we're only at the beginning of that concept, which makes sense because when they discovered electricity, they didn't stop with the Van de Graaff generator. They figured out how to build entire ecosystems around the electricity generators to actually make it work. And that's what we're seeing with AI. And my question at the end will be, do you agree?
Exactly.
The second thought was, and this was kind of, oh, wow. In engineering, when I undergrad, we had control systems and feedback systems. And holy cow, the concepts that go into a harness or a framework to control these things,
Yep.
that's control systems. Wow.
Yeah.
So I need to get out my old book. Do you agree?
No, very much so. And like, if you're familiar with the operating systems, that's literally what a lot of context engineering and like managing the memory and the context of what an agent sees at the right point in time literally is. Because again, like if I'm getting all of this feedback from a domain expert, do I just keep overpopulating that feedback prompt or system prompt? No, like I need to work through like a get difference to identify, is that redundant information? Am I pulling out something? How do I keep it concise? So I think a lot of traditional engineering concepts are just coming in, and that's what's giving us these improvements over the past year or so, rather than just raw intelligence.
And one more quick question, if it's quick. How would someone engineer a task when you observe as a human that it's reasoning using incorrect assumptions during its chain of thought or intermediary step?
So is the question, how would you engineer a task when you find something like this?
Mhm.
Okay. So I think this is fundamentally important, especially in cases where you're signing off on audit, for example. So, I mean, people are probably familiar with using a language model as a judge, right? Again, personally, I don't like it, or, because it's theoretically indefensible with committees, with governance committees that are reviewing your solution, right? So I think the fix for that is bringing in deterministic systems to check probabilistic systems as a field that we call automated reasoning or like symbolic logic based checks. So you're taking your policies, you're creating mathematical or like Boolean logic checks out of them, and then verifying that the outcomes are right. That, in some sense, addresses the hallucination aspect that's being referred to. So I would consider that a part of it. There are other aspects where you can risk gate outcomes, as in like it's called hallucination risk gating, where you're mathematically given, the probability of that particular word, you're gating it and not letting it be produced. Because what we do right now is, we say, give me an answer, but then if you're not sure, don't say anything. Like, I'm just praying that that instruction is followed. But in reality, like it is a mathematical operation that needs to occur for you to hold that hallucination from occurring. So these mathematical ways of addressing them is where we go generally.